presentation and video file. Well, previous lesson, we discuss about how to create objects. Now let's discuss about it in details, and let's discuss about special functions that called constructors and destructors. But let's briefly review what we discussed about on previous lecture. We discussed about object declaration, how to work with objects, how to get access to the member functions and member fields. And we consider a very important feature, so-called this pointer. From the general point of view, the object can be considered as a variable of a class data type. The class is a new user-defined data type, and the object is a particular variable of this user-defined data type. And similarly to the declaration, oh sorry, not declaration, but creation of the variables of built-in data types, there are two ways to create an object, a variable of a user-defined data type. First way is static. We can create this object statically, and we can create this object dynamically using operator new for allocating the memory. For example, if we declare a class complex, then I can create objects of the class complex AB like this, statically, or I can create the pointer. Let me write here P again, PA, and here PA is a pointer that points to some object in memory. This object is created by means of this operator new. We consider later some more complicated examples of object creation. And at the same time, let me show you these examples in Visual Studio. I also want to tell that the class complex can be declared not in one CPP file main, but in header file complex.h. In this file, we can place declaration of class complex with data and functions, and in class in file complex.cpp, we can place declaration of sorry, not declaration, but definition of their methods. The method can be declared here. For example, add or append. It is just a declaration of the method, and the definition is placed here in a file complex.cpp. This prefix corresponds to the name of the class to which this function belongs to. We consider these functions on previous lesson. And if we declare this class on this way, after that I can create objects statically. A, B, C are variables of the type complex, or dynamically. Here PA is a pointer to the class complex. If the object is created statically, I can call the method using point. If the object is created dynamically, I can call particular method using arrow. If you is arrow, Visual Studio automatically shows you the list of the methods that you can call here, the list of public methods. Moreover, as I told you, I show you this example. If you put here any comment, for example, this method or this function outputs the number the screen. Well, if you put oh, sorry. You should put this comment before. You should put this comment not after the method, but before the method here. Well, if you put this comment before particular method, for example, print, in this case, if you open this, if the Visual Studio opens you this list, you will see your comment. You will see your comment here. This function outputs the number to the screen. Okay, and if the objects are created statically, in this case, compiler deletes it automatically when the program is finished or when you're out of the block where these objects are created. But if you create the object dynamically, in this case, you should delete it manually using operator delete. Well, we discussed about it in details on previous lecture. I just repeat the main points. Well, and the question is how the objects are represented in memory. And what we know from the previous lecture, every object has own data and the memory for their data members are own. So every object has own memory for the data, but their functions implementation is common for all the objects of the same type. This feature is shown on this diagram. Suppose that we create two objects of the type complex A and B. These objects are stored in computer memory, and each of them has its own data, real and imaginary part, and common implementation of the methods. When we call their particular method, for example, set real or set image, we call it from specific object, A or B, and every method has one hidden parameter, the pointer this, the pointer which points to the object that call this method, that call this function. Here, the function set re gets the pointer this that points to A. If you call it B point set re gets the pointer this that points to B. Usually when we implement the method, it's not necessary to write this and pointer, because by default the identifier re corresponds to this object. But to stress it, just to stress it, I can put here this point re.
How come the other one has a point, not an arrow?
What?
In the present, I said, how come in the presentation, even though it's dynamically stored, it has a point? Point is for static, right?
Yes, but A and B are objects that create statically without new. Dynamically,
Oh.
if we create it using new, like this.
Okay, yeah, and the aspect. Okay.
Well, but now let's consider one more feature. But before we consider it, just new information that when we create the object statically, it will be placed in computer memory that is called data segment or the stack segment. And when we create the object dynamically, this object is placed in the segment of computer memory that is called heap. But pay attention, what's written here? Some parentheses. Why it can be written here? It's not a mistake. Let's look to this. I can write declaration of the object without these parentheses and with parentheses, and it will be okay. Also, sorry. Why it's a mistake? Okay, it's let's discuss about it later, because it was working in previous version of Visual Studio and it's not working now. So what is the meaning of these brackets, of these parentheses? This is the first question, and the second question is, can we synchronize the object creation with some additional activities, such as data initialization? For example, if we create an object like this or like this, all the member fields are undefined. I show you this feature. Let's check it again. Let me comment this part of the program. Suppose that I create A, B, and C, and I want to print the real and imaginary part of the object A to the screen. And I call the function print. What will we see on the screen now? Can you guess? Let's look to the function print. Function print outputs to the screen real and imaginary part of this complex number.
We'll see the real part.
We see undefined values. I told you, I already told you that if I just create the object.
Oh, you didn't assign any numbers.
The values of the data members of the data fields are not defined. And in this case, I'll see on the screen some undefined value plus I times another undefined value. The member fields re and im are not defined. And this question is related with this situation. Can we initialize the data at the moment of creation of the object? And the answer is yes. Yes, we can do it. And this action can be done using some special member function that is called constructor. Constructor is a special member function that is automatically called when the object is created. There are many features of constructor, but we consider this one first of all: data initialization. Using constructor, we can initialize the member fields in particular class. So this is one of the main features of constructor. And there are a lot of other features like memory allocation, copying, typecasting, and so on. How to declare constructor? Constructor, again, is a special function. That's why there is some rule for declaration of constructor. This is a general form of the declaration. The name of the constructor is the same as the name of the class. After this name, in parentheses, we write a list of parameters. List of parameters, just a usual list of parameters like in all other functions. Constructor doesn't return any value. It means that the type of the result of the constructor is not int, is not double, even it's not void. It's just nothing, empty. No result, because constructor is a special function. I can declare constructor inside the class declaration if constructor is very simple. If it consists just of 2 or 3 lines of code. If constructor is a large function, it can be defined outside of class declaration. But in the class declaration, it must be written a prototype of the constructor. On this presentation, you can see the example of constructor for the class complex, but let's consider it in Visual Studio. First of all, let's write here the special section is just a comment, constructors, because a class can have not only one constructor, but several different constructors. According to this general form of the constructor declaration, the name of the constructor must be the same as the name of the class. In our case, it's comp. Then I should write parameters. As far as I want to initialize the data members, it's enough to pass here just 2 parameters. The real part and imaginary part of the complex number. This is a prototype of the constructor. In our case, constructor is very simple. That's why I can write the implementation of this constructor right here in H file. Real equals to underline real and image equals to image. Only the difference that I want to I should use a large syntax. Well, what happens? Now, when the object is created, I must specify real and imaginary part for this complex number. And these 2 values will be assigned for real and imaginary part of the number that I declare. Actually, I can write here this. But I can skip it. Usually, this and arrow is skipped when it's obvious. Well, let's come back to main. See that this line becomes incorrect. This line becomes incorrect because I write a constructor. Now, when I create an object, I must write two parameters. And it's written also in their present or no, I forget right here. Sorry, in presentation, the example of creating the number. I'll do it in Visual Studio. A, for example, 1 and 1. Please look to this line. Visual Studio shows you the parameters that you must specify to create a particular object. Now, when you create A, the real part will be 1, imaginary part will be 1, 2. Let's assign 2. Okay. For B, for example, I can write 0, 1. For C, 1, 0. And after that, the object A will have values or sorry, all, of course. Here I should write also 0, 0 because I created the variable result. Now it's okay. And if I run this program now, I'll see on the screen 1 and 2. Oops. Let me run it again. Yeah. I'll see 1 plus I times 2.
Constructor is just like a function.
Yes. Yes, you're right. Constructor is a special function that is called when you create an object. And you can pass here appropriate parameters.
Okay. Any object or just complex or like special objects?
Yes, yes, yes. And after that, I can print. Let's print, for example, C point print. Yes, we see 1, 1 and 0. So again, constructor is a special function. Constructor doesn't return a result, and the name of the constructor is the same as the name of the class. You can declare a constructor here, but suppose that the border of the function, border of constructor is very large. In our example, of course, it's small, but imagine that this function is large. In this case, write here just a prototype of the constructor and implementation of constructor can be written here in file complex CPP. What should I do? What should I do here? Let's copy this line. And I must write complex for dots complex. This complex means the name of the class. This complex means the name of the function, the constructor. And here the body of constructor. Sorry. Real part equals to real, im equals to im. Now I write the implementation on a separate file. It's working. Well, let's consider some features of constructor. Constructor doesn't return any result, even of void data type. So when you declare the constructor, no result, no double, no void, just the name of the function. This is the first feature. Next feature. A class can have several constructors with different list of parameters. For example, it's in our example, it's very natural to assign 0 value to real and image by default. In this case, I can write here these default parameters. Real equals to 0, image equals to 0. These values, even let's do it 0.0 to stress that this 0 is not a real constant. It's not a double. Sorry, it's not integer constant, but a double constant. These values should be written only once, only in the prototype of the constructor. Here, the implementation still be the same. What does it mean? It means that if I write declaration of the object without parameters, these parameters will be taken from the list of the default parameters. And if I write here a print, I'll see 0 and 0 because I write here 0 by default. Zero plus I times 0. We discuss about default parameters when we consider functions, and here we use it. We use this feature of C++, the default parameters. But if I specify only one parameter, for example 10, this value will be taken as a first parameter in the list, and the second parameter will be taken by default.
So it'll be 0.
Yeah, in our case it will be 0. When I call a point print, we will see on the screen 10 plus I times 0. If I put 2 parameters, both of them will be taken from this initially from this list, but not from the list of the default parameters. And I'll see 10 and 2. If the number of parameters will be larger, compiler outputs your mistake. Well, let me repeat that the default parameters can be mixed. I mean that one parameter may be obligatory and their second parameter may be default. In this case, all of these declarations will be correct. This declaration will be correct too. In this case, we will see on the screen a that equals to 2 plus I times 0. But if I delete this value, if I delete all of the parameters, the program becomes incorrect because here one of the parameters is obligatory. Okay, let's assign the default values 0. The program becomes correct. And now the next feature that a class can have several constructors with different parameters list. Suppose that our class a constructor without default values, re and im. Write another constructor without parameters that will assign 0 values to re and im. For simplicity, I write their implementation here in H file. What we have now, we have 2 constructors. The name of the constructor must be the same as the name of the class, complex, but these constructors differs in list of parameters. Here, this constructor requires 2 double numbers. This constructor can be called without parameters, without any numbers. The program is correct, but pay attention. If you assign here the default values, the program becomes incorrect. Why? Because compiler cannot decide automatically what constructor to call here. I create an object A of the type complex. The type complex has 2 constructors. this constructor without parameters and this constructor can be called without parameters too, because I assigned here default values, and compiler cannot decide automatically what constructor to call. That's why the program is not correct. If I delete here the default values, the program becomes correct. And one more feature, that constructors cannot be constant, virtual, and static. We discuss about it later if we have a time. Well, when a constructor is called, the answer is very simple. The constructor is called when the object is created. But we consider two types of creation of the object: static declaration and dynamic declaration. And the constructor is called when the object is created. In this case, constructor is called when you write this line. In the second case, constructor is called when you write operator new. Let's consider it here. Suppose that I declare the pointer PA. But I write PA equals to new complex not at the moment of the declaration, but a few lines below. It means that here I just create a pointer to the object, but the object is not created yet. The object will be created only when I call new. Only after this I can, for example, call any function, for example, print. What will we see on the screen now? We see 0, 0 for A, and we see 0, 0 for PA. 2 times 0, 0. Let's output end of line. Yeah. But suppose that I forgot to write new. How do you think?
Error. Will be an error.
Error, but when? When we see this error? When I try to compile this program, compiler tells us, okay, succeeded.
Oh, then it'll be an unpredictable number for the imaginary.
No.
Oh.
No. Let's look what we see on the screen. We don't see nothing. The program will be interrupted. The program will be crashed. The program crashed here. Because in this case, when I don't assign the values to the real and imaginary part of the object A, the object A exists. But here The pointer PA points to nothing, no object. There is no object to which this pointer points. That's why the program crashed here. You must write new when you declare the object dynamically. Now it's okay. And also you can write here parameters of the constructor, like you write it here. When you create an object dynamically, you can write also the parameters of the constructor at this moment when you call new. Now we will see on the screen 2 and 3 for the object with the pointer PA. Well, again, I repeat, the constructor is called at the moment of creation of the object. When you create it statically, the object's created when you declare it. When you declare the object using pointer, the objects declared when you're not created when you call operator new, but not at the moment when you declare a pointer.
Okay.
Well, let's consider some more, one more feature. Let's consider constructor that gets as a parameter another complex number. For example, suppose, let me delete these lines, and suppose that I create these three. Okay, suppose that I create B and C. I want to create an object A the same as B. I want to pass the parameter here. What should I write?
The parentheses. Inside the parentheses.
I should write here another constructor. And this constructor must get the object of the type complex. For example, complex T, some variable. One more constructor. You see that this constructor, the first one, let me write it in one line because it's very simple. This constructor without parameters, this constructor gets 2 double numbers, and this constructor gets as a parameter 1 complex number. Here I write just a declaration. Now let's write definition. Let me copy this part of the code. Complex, complex, and one more complex. Complex T what will be the real number, real part of this? Same as real of t. What will be imaginary part of this object? It will be the same as im. Okay, and the last feature, as far as we pass here the type, the variable t of the type complex, this parameter is not changed during this function. So this parameter must be transmitted to a function by constant reference. Not just complex, but constant reference to complex. Const we write to avoid modifications of the object T, and refs we write to pass the not a copy, but reference to actual parameter. Now the program becomes correct. And what happens at this moment? The value of A will be the same as the value of B. And when I call a.print, I'll see on the screen 0 and 1. Because previously I assigned 0 and 1 for the object B, and now I assign the values from the object B to the object A. Well, do you have some questions about constructors?
No, not really. Wait, I have a question about the A and B. Didn't you assign it to T? Not A, right?
Sorry, please repeat your question.
Didn't you assign it to T, the parameters from B?
Well, what is T here? T is a formal parameter. It just indicates that this constructor should get a reference to some object. And the actual parameter is B. B is a parameter. And here, T will be just another name of B.
Okay.
It's not a copy. It's just a alias of B.
Okay.
Please, there are other questions? Well, actually, any class can and often should have several constructors. The default constructor that can create the class without parameters. Constructor for member fields initialization. This constructor gets some parameters and assign their values that it get to the member fields. And copy constructor that can copy one object, the values from one object to another object. In some cases, constructors, in the list of constructors, it will be useful to write typecast constructor to convert the type from one data type to another. Well, I already told you about it. Let's repeat that default constructor doesn't have parameters. It doesn't have parameters. But if you do not provide a constructor, it will be created a compiler. But if you implement some non-default constructor, the default constructor will not be created. Let me show you this feature in Visual Studio. Well, suppose that your class has two constructors. One constructor is default without parameters, and the second constructor has some parameters. Now, let's come back to the first example when we just declare several objects without parameters. And suppose that I delete all the constructors. Well, I delete all the constructors, but the program is correct. Why? Or, sorry. It's not correct because here I should delete 0, 0. Now it's correct. Why? If you don't specify constructors, compiler create constructor automatically. But this constructor will be very simple. It's just assign undefined values. But the program is correct. We can run it and we can see undefined values. Well, the next step. Suppose that I create some constructors with parameters. Okay. I declare these two constructors, but the program is not correct. And when you see the list of the mistakes, list of the errors, compiler outputs you this error. no appropriate default constructor available. Well, it means that if you implement some non-default constructor, a default constructor will not be created. So when you implement these non-default constructors, default constructor will not be created. So in this case, you must create it manually. And now the program becomes correct. Well, some examples. Of course, when you write complex A, it should be written like this, complex A. Why? Because when you try to write parentheses after A, the compiler can't understand, is it an object declaration or a new function prototype? But in the second line, in this line, these parentheses is okay. But usually empty parentheses are omitted when you create an object with the default parameters. Next feature. This is a constructor of data initialization. This constructor gets two numbers and assign these numbers to corresponding data members, real and imaginary part of their complex number. And usually class can have several constructors with different lists of parameters. The compiler can understand which constructor to use. It depends on parameters. When you write declaration without parameters, compiler called default constructor. When you write a declaration of the object with parameters, compiler called the constructor initializer. It depends on the list of parameters. That's why a list of parameters is very important. In our case, we see on the screen 2 plus I3. Well, some examples. These examples I already showed you in Visual Studio. That's why I skip this class. In some cases, you can write assignment using special initializer lists. Not like this, but like this. real and imaginary part. Let me show you this example in Visual Studio. These lines I can comment, but after the declaration of the function, I can put here list of initializers. Real, oh, sorry, here. Wait a minute. Real with the value real and imaginary part with the value im. These two forms of initialization are more or less the same.
This is more than just a prototype, right?
No, it's not in the prototype, but in the definition okay. Of the function. And why we, when we should write it, when we should use it. And these initializer lists is used when we work with constant references and objects as their member fields of another classes. For example, if I declare some class example and I declare constant, some constant in this class, and this constant must be initialized with some value, I can write initialization list. It's obligatory when we work with constant, members.
Oh, okay.
Well, this is a copy constructor. We already discussed about it. Copy constructor gets as a parameter constant reference to the object and assigns the values. To the corresponding data members. Well, the copy constructor can be called, or let me delete it. It's usually deleted. It's usually called when I write it like this, complex AB, and also when you write complex A equals to B in the declaration of a new object. Also, copy constructor is called when you pass the parameters into the function. I mean, when you pass there some data type, some object of the type complex to another function, or if you return some value of the type complex from some function. Well, let me write this constructor in usual form without initialization list. Please Questions? You're welcome. Do you have any questions about different types of constructors?
No, sir.
Complex, for example, Z that equals to A. At this moment, also the copy constructor will be called.
So this is a faster way to do with the T, right? This is a faster. I said this is a faster way to copy the function with like the way we used T earlier.
No, T is just a parameter. It doesn't matter. I can use any other name of the variable here. But in any case, if you write it like this, or if you write it like this, copy constructor will be called. The value of a new object will be the same as the value of this object. And if you called here print for the object Z, we will see the same values.
Okay.
Well, I think it's enough for this lesson. And I don't remember exactly the schedule. Maybe the next lesson will be the last. And on this last lesson, we will discuss about operator overloading.
Oh, okay.
How to create new operations in your class with standard names like plus, minus, plus equals, and so on.
Okay.
Do you have any questions?
No, sir.
Well, if you don't have any questions, later this day I will send you the video file of this lesson and I will send you the presentation. Let's stop